Hello, my darlings. Okay, so today we're going to talk about interpreting the meaning of the derivative in context. So how do we determine the units of the derivative? That's the first thing. Now remember, a derivative was a rate of change. It was the change in the y values over the change in the x values. And notice f of x is in the y position. So when we're looking for the units of f prime of x, or the units of df dx, we take the units of f of x and divide by the units on x. So let's look at an example. The function f of t models the number of jelly beans in a bowl after t hours. So what are the units of j prime of t? So that's the change in j over the change in t. So that would be the number of jelly beans per, and the unit on time is hour. Now, if I ask you what are the units of j double prime of t, the second derivative, remember that's the change in j prime over the change in t. So that's jelly beans per hour, Okay, there we go. So now how do we interpret a derivative value? A derivative f prime of x gives the rate of change of f of x at one particular instant in time. And to interpret a value of f prime, you must include the big four. You have to have the context. Don't just name the function. Include what the function is modeling. Is it the number of people entering a park, the number of people leaving the park, the number of bananas on a table? What exactly is happening? The units. You must have units for both the answer and the x variable. Okay, usually it's time, but not always. Instantaneous time must be clear. At what time? So the time has to be very specific. The word rate should be somewhere in your sentence, okay, to indicate that this is a rate of change. So derivatives tell you how fast a function is changing, increasing or decreasing. If it's increasing, our derivative is positive because that means there are positive slopes and it's going up. If it's decreasing, that means our derivative is negative because our slopes of the tangent lines and the slopes of the derivative are negative, which means it's going down. Now, given the function f of x and the derivative f prime of x, usually this is a template you can start with to model interpreting them. When x equals and you insert whatever the time is, or at such and such time, now define the context of the problem. The number of people leaving the park, the number of people entering the park, the number of bananas on the table, the number of coffee beans in the jar, whatever it is. Determine whether it's increasing or decreasing, and at a rate of, make sure the units are there. Remember, you've heard me before say use nut, the noun, the unit, and the time. All of that has to be there. Let's see if we can do an example. A pie is taken out of the oven. The temperature of the pie in degrees Fahrenheit, t minutes after the pie is removed from the oven. So the time is the minutes after the pie is removed from the oven, is given by the function p of t. Interpret p prime of 10 equals negative 13 in context. So here, our t is 10, which means that is 10 minutes after the pie is taken out of the oven. And all I've done so far is tell you the when. Now what is the function? The function is the temperature of the pie is given by that function. So the temperature of the pie, now is it increasing or decreasing? Since it's a negative 13, the temperature of the pie is decreasing at a rate of 13. Now we need the units. The units on P is temperature in degrees Fahrenheit, so degrees Fahrenheit per, and the unit on the time was minutes. And that is our interpretation. Now we want to make sure we know the difference between an instantaneous and an average rate of change. Decide whether the phrase used in each of the following problems corresponds to an instantaneous rate of change or an average rate of change. Remember that an instantaneous rate of change happens at one specific moment in time. An average rate of change happens over a period of time. So over the time interval from t equals 2 to t equals 5, that's a period of time. That's an average rate of change. After 3 seconds have elapsed, that's a specific moment in time. That's an instantaneous rate of change. At noon, that's a specific time. That's also an instantaneous rate of change. Now, what is a rate of change function? A rate of change function helps us predict how a quantity will change over time. When is the quantity increasing? When is it decreasing? And how fast is the quantity changing? Now, here's the key here. The rate of change function is the derivative of the original function. However, derivative notation is not always used. Example, A of t could represent the rate at which water fills a container. That is a derivative of another function that we don't have, okay? But it is still a rate of change. The rate of change function could be given as a graph, a table, or an equation in any of the three forms that we look at. Despite varying contexts, whether it's the number of mosquitoes, the tons of gravel, the number of bananas on a table, whatever it is, the same key skills are addressed. Interpreting the derivative value in context using correct units, finding or approximating a derivative of the rate of change function, which is a second derivative, and determining when a quantity is increasing or decreasing based on its rate of change of the function. These are the three things that they will ask you, okay? So let's take a look at, this is part of an old AP problem, okay? So here, people enter an amusement park at a rate given by, so this is a rate, E of t is a rate, even though it doesn't say it's a derivative, it is, where E is in people per hour and t is in hours after midnight. Okay, so the first thing we need to do is find E prime of t. Now this is where we're going to go get our calculator. All right, let's go get our calculator and find E prime of 11. Okay, so on a calculator page, we're going to use our template key. We're going to get the d box of box. We're taking our derivative with respect to t. We're going to tab over because our function is defined in terms of t. We need a fraction template. We have 15,600 over t squared minus 24t plus 160, arrow out of the parentheses. Now we need the such that. Control equals such that t equals, and we wanted this at time 11. Hit enter. I'm even going to do control enter. That way we have an idea of what that number is. Okay. Okay, so we found that E prime of 11 is 107.958 using our calculator. Now, using correct units, let's interpret the meaning of the value in the context of this problem. So remember that 11 is our t value, which is the hours after midnight. So 11 hours after midnight would be at 11 a.m. At 11 a.m., the rate, now what did we have? The rate people enter the amusement park. The rate at which people enter an amusement park is, now this is a positive answer that we got, so we have increasing at a rate of, and we said 107.958, but we need the units. Remember, the units on E were people per hour, per, and the units on time was hours. And there is our interpretation. So some key connections to make sure you're familiar with. Remember that Q of t is not changing, means the derivative is 0. If Q of t is increasing, that's when our slopes are positive. That means Q prime of t is positive. If Q of t is decreasing, our slopes are negative and Q prime of t is less than 0. Those are important to know. Some more verbal descriptions of derivatives. We're going to complete each of the following verbal descriptions by filling in the blanks with information that is missing. Be sure to include appropriate units, and the first one is completed for you as an example. So if V of t gives the volume of water in a tank in liters after t minutes, then V of 3 equals 20 means that after 3 minutes, there are 20 liters of water in the tank. Now V prime of 3 equals negative 2 means that after 3 minutes, the volume of water in the tank is decreasing, because this is negative, at a rate of 2, and the units on V was liters, and the units on time per minute. Okay, now let's see if we can do some. A of t gives the area of the surface of an oil slick in square kilometers after t hours. A of 24 equals 17 means that after 24 hours, because our time t in here is 24, after 24 hours, the area of the surface of the oil slick is 17 square kilometers. A prime of 5 equals 4 means that when 5 hours have elapsed or passed, the area of the surface of the oil slick is, now because it's positive, it's increasing at a rate of 4. The units on A is kilometers squared per. The units on the time is hours. Number 2, C of x gives the cost in dollars of digging a hole x feet deep. C of 20 equals 140 means that it costs $140 to dig a hole that is 20 feet deep. C prime of 20 equals 5 means that when the hole is 20 feet deep, the cost of digging is increasing at a rate of $5, that's the unit on C, per the unit on the X is feet. Now there are also things called rate in and rate out problems. Okay, some quantities are determined by 2 rates, a rate in and a rate out. The number of people at a soccer game is determined by the people that enter the stadium and by the rate that people leave the stadium. So you're adding the number coming in and you're subtracting the number leaving. The volume of water in a tank is determined by the rate of the water fills the tank and the rate that the water leaves or leaks out of the tank. So you're going to add what's coming in, you're going to subtract what's leaving. To find whether a quantity is increasing or decreasing at a specific time or interval, compare the rate in and the rate out. Now, some pro tips here, some things that are really good to know is these are usually calculator active on your AP exam. So the first thing you should do is put your rate in and your rate out into F1 of X and F2 of X in your calculator. You can also define a new function clearly labeled on your paper. If it's not labeled, they don't know what it is and they won't read it and won't grade it. That represents the overall rate of change. In other words, rate in minus rate out. You have to name this function though. Don't forget to name it. Give it some kind of name. And then in your calculator, put it in F3. Okay? Refer to the functions by their function name, B of t, W of t. Don't use calculator keys. Do not write F1 of X, F2 of X, F3 of X. They do not want calculator notation. I know in statistics, AP Stats they do. AP Calc, they want to see no calculator notation. Okay, let's try an example. The penguin population on an island is modeled by the differentiable function P of t. So remember, this is the penguin population on an island, okay? And we're only going from 0 to 40, where t is in years. There are about 100,000 penguins on the island at time t equals 0. The birth rate for penguins is modeled by B of t, penguins per year, and the death rate is modeled by D of t, penguins per year. So the question is the penguin population increasing or decreasing at t equals 5 years? And give a reason for your answer. So the first thing is I want to know the rate. So I'm going to make a new function r of t. If I want to know if the rate is of the population, and you might want to call it p for population, that's fine. If it's increasing or decreasing, I have to take my birth rate, which is how they're increasing, and subtract my death rate, which is D of t, okay? and then we're going to find R of 5. If it's positive, the population is increasing. If it's negative, the population is decreasing. Now we're going to need our calculator for this. So we're going to, and this would not be on your test paper, but in F1 of X, we're going to put our B of T. So go to your calculator and start doing this. So we're on a graph page, and in F1 of X, we're going to put B of X, which is 100 times e raised to the 0.06. Make sure that t is an x here. Then we're going to go down to f2 of x, and I know I don't see the graph, that's okay. This was supposed to be 1,000. It's okay that I don't see it, I don't really need to. In f2 of x, we're going to put d of x, which is 250 times e raised to the 0.1x. And then I'm going to come down to f3 of x, and I wanted b of x minus d of x, which means that's f1 of x, close it, minus f2 of x, and hit enter. Then I'm going to go to a calculator page. And now I'm going to find f3 of, and we wanted this at time 5, and there is our answer, 937.678. Okay, so from our calculator, we found that R of 5 is 937.678. Now, this is a positive number, which therefore means the penguin population is increasing, because that's positive, at time t equals 5 years, since R of 5 is greater than 0, which means, by the way, that the birth rate is greater than the death rate at t equals 5. Okay, guys, we're going to stop here for today, and we're going to practice more of this in class, but keep in mind, make sure when you're interpreting that you have all the information. Exactly when is it happening? What is the context of what's going on? Use the word rate. Is it increasing? Is it decreasing? And don't forget to watch the units. All right, guys, have a great day.